So the equation that we had choose is fx equal to 5x squared plus 3x minus 1. First, we will need to make a table. The error that we have set in this equation is in the range of 0.05. For the iteration, we will start from 0. The value of a and b is 0 and 1. The first one we will do for fa, just simply substitute the value of 0 into the equation and we will get fa equal to -1. Same goes to fb, we just substitute the value of b equal to 1 equal to 7. Moving on to c, we will plus a and b divided by 2. And for fc, we just substitute the value of midpoint into the equation, which is 1.75. Then, we will do for fa times fc, and we will get -1.75. For fb times fc, we get the value of 12.25. fa times fc and fb times fc, the value that we get, either greater or smaller than 0, it will tell us which direction will the graph move. If the value is less than 0, then the graph will move to the left side. If the value is greater than 0, then the graph will move to the right side. And last but not least, we'll find for the error, which is b minus 1. For the first value that we do, we get the error, which is 1, but it had exceeded the range that we have set, which is 0.05. So we need to repeat the step again and again until we get the range that we want, which is 0.05.
After that, instead of inserting the code one by one, we can just break it down the table. The value then will be calculated by itself. We can observe that starting from the iteration 5 and below, the value for the array is less than 0.05. We will highlight the value. Next, we will create the table for the graph. The value we will insert for x is 0.01, 0.02 and so on. While fx is the value of the equation for each value of x. From this table, we can create the graph that we need.
Let's create vertical lines to depict our higher and lower boundaries at iteration 5 by using the same x-axis and inserting the higher and lower boundaries. And you will get two vertical lines. Next, you can add the validation of the root that we have between two boundaries by using the if statement to determine whether it is true or false. If it is true, it means that at least one root is present.